In this video, we're looking at the material conditional. So SL is a truth functional logic, so the conditional is going to be truth functional as well. So this here is the characteristic truth table for the conditional. Unlike and or, the order matters for the material conditional, right? P implies Q does not mean the same thing as Q implies P. Right. So P, the P here, right, or the sentence that comes before the symbol here, before the conditional symbol is called the antecedent, and the one that comes after is called the consequent. Um, this symbol here is referred to as a horseshoe. That's the symbol that we use to represent this. It's also common in other systems of logic to use other symbols. Arrows are particularly common for this. But this is the symbol that's used in SL, and this is not difficult to draw. So you are expected to use the horseshoe instead of an arrow or anything like that. Um, okay, so the first question, I guess, is this: why do we have this truth table for this? Um, the thing is this: in natural language, conditionals, um, if then sentences are not usually truth functional at all, right? So take a sentence like, if it rains, then the grass will grow. What this actually says, or what it means, is something like, rain will cause the grass to grow, right? It's expressing that there's a connection between rain and the grass growing, right? Some sort of causal connection or some sort of relevant connection there. This has given rise to a lot of study of what are referred to as relevance logics, or relevant implication, where what are studied are these they're referred to as relevant conditionals, where the idea is you try to get logics that handle um, this sort of connection between these, right? Where in order for an if then sentence to be true, there actually has to be some sort of connection between the antecedent and the consequent. Something like what you would expect to find, right? In if it rains, the grass will grow. The problem is that first of all, like it's really, really difficult to represent these relationships formally. I mean, your semantics ends up being extremely complicated. But the bigger problem is that logics like this are not they're not decidable. You don't have mechanical procedures for determining whether sentences that contain these conditionals are true. With the truth functional logic, you do have this, right? You have mechanical procedures, right? In fact, relatively simple algorithms in some cases for determining whether these sentences are true or false. So that's a huge advantage to the truth functional logics. So in order to make sure that we can make use of these algorithms and have a decidable system, the material conditional is basically like a truth functional approximation to the way that if then in natural language actually works. And so the truth table, the way that it gets generated is basically this. So, I mean, let's suppose that we're still thinking about if then in the natural language terms, right? Where if P then Q requires that there be some sort of connection between P and Q, whether it's causal or relevant or otherwise. Okay, so if the antecedent is true and the consequent is false, right, then clearly there's no connection between them, right? So if it rains and the grass doesn't grow, then we know that it's false, that if it rains, then the grass will grow. So we know that the conditional in that case is going to be false. Now, the other three cases are problematic, right? Like, look at this one here. Suppose it rains and the grass grows. Um, I mean, that doesn't tell you that it was because of the rain that the grass grew, right? You don't know that, like, it doesn't, the fact that both of those happened doesn't establish that there's actually the connection that you would need between those. So in these three cases, we don't know. Here we know that there's definitely not a connection. In these three cases here, right, there might be one, And so for the truth functional material conditional, what we do is we just basically, stipulate that it will be true in all of these cases. So the material conditional will be true anytime there's the possibility of a connection, basically. It's the weakest possible conditional, effectively, is what it is. Um, and yeah, and then the result of this, so this is how you can characterize it, right? It's false if the antecedent is true and the consequent is false, and then in every other instance it is true. And the result of this is that it can be rigorously evaluated, and it is close enough to an actual conditional that you can use it to symbolize English sentences without too much loss of meaning. So when you're paraphrasing material conditionals, the way that we paraphrase them is with if then. So if I am wearing shoes, then I am wearing socks. Underline both of these to indicate that they're logical operators. The if marks out the where the antecedent is, the then marks out what the consequent is. If you want, you could put parentheses around it. I mean, given that you're marking both the antecedent and the consequent, the parentheses aren't really necessary. But like if you're doing that with the other operators, you might want to do that with the conditionals as well. Um, in English sentences, and actually, if you look back at the slides, right, there have been several examples of this already. Um, then is very often dropped. So if this is Belgium, it must be Tuesday, right? When you paraphrase this, it's going to turn into if this is Belgium, then it must be Tuesday, because the then here has been omitted. Another thing that you'll often find is where the components get rearranged, right? So they don't always go antecedent consequent in that order. Sometimes the consequent will come first. So you can have dessert if you eat your spinach. Right here, the antecedent comes after the consequent. So you need to rearrange this when you paraphrase. If you eat your spinach, then you can have dessert. Now, the thing to remember though is particularly because of the fact that you can have if in the middle of a sentence, right? So if and only if, these don't mean the same thing, right? And it's really important to keep the difference straight. If always marks the antecedent of a conditional, regardless of where it occurs in the sentence, right? So you will win the race if you believe in yourself. If you believe in yourself, then you will win the race. Only if marks the consequent of the conditional. So you will win the race only if you believe in yourself. The way that you paraphrase this is if you will win the race, then you believe in yourself. Now, the difference between these two is actually the difference between what are referred to as necessary and sufficient conditions. So you will win the race only if you believe in yourself. What this says is that believing in yourself is necessary for winning the race. So if you don't believe in yourself, you won't win, right? If you did win the race, then you must have believed in yourself. And that's something that's plausibly true, right? Like it's plausible that confidence is important enough in athletic success that in order to win the race, one of the conditions that you have to satisfy is you need to believe in yourself. You will win the race if you believe in yourself says more than that. It says that believing yourself in yourself is sufficient for winning the race. So all you have to do is believe in yourself and you will win. So it doesn't matter if you've trained, it doesn't matter if you smoke 2 packs a day, it doesn't matter if you're completely out of shape. None of those things actually matter according to this, right? All you have to do is believe in yourself. This is actually, in fact, this specific example is something that people, when you look around, like on the internet and stuff like that, you find that people regularly confuse these. And, very often you find people saying that all you have to do is believe in yourself and then you will succeed. And that's not plausibly true. There are a lot of other things that go into success besides just believing in yourself. Um, so yeah, so the difference between if and only if is also the same as the difference between necessary and sufficient conditions. And yeah, be careful not to confuse these. My original example there was going to be somebody trying to win a marathon, despite the fact that they chain smoked. But then I found out that this guy here, his best marathon time is 3:28, which is extremely good. Okay. You can also have conditionals that don't have ifs in them at all. Um, so provided that and assuming are often used to mean if, particularly in like legalistic sort of documents, right? So take like a representative can receive an additional housing allowance provided that his or her residence is outside the capital region. This you would paraphrase as if a representative's residence is outside the capital region, then the representative can receive an additional housing allowance. The most complicated ones to symbolize are the ones where you don't actually have any kind of distinctive word that tells you that what you have is a conditional. And in that case, what you have to do is you have to think about what the speaker would intend in the context in order to recognize that what you're looking at is actually an if then sentence. So take, you can borrow my car as long as you don't get the carpets dirty. As long as this is something that normally talks about times, right? So you take a sentence like you can use the spare room for as long as you are in town, right? This is saying that you can have the spare room for the period of time in which you are in town. The thing is that that interpretation here doesn't make sense, right? I mean, you can't interpret this sentence as meaning something like, well, you can borrow my car for the period of time in which you don't get the carpets dirty, but then it's fine for you to get the carpets dirty like immediately afterwards, right? Like that kind of thing doesn't really make the temporal interpretation doesn't really make sense here. The more plausible way of interpreting this, though, is to suppose that what it's doing is it's posing a sufficient condition. So if you don't get the carpets dirty, then you can borrow my car. Right. So it's giving you a condition on what's being done. And there are quite a lot of sentences that you'll find like this. When is another example that, or another word that will be used sometimes in place of if. And the only way that you'd be able to identify it is to think about the fact that where a temporal interpretation, a strict temporal interpretation doesn't make sense in that case. And so then you would use that to recognize that what's really being talked about there is a conditional, right? What's being proposed is a conditional. Um, so that is a basic rundown of how conditionals work in SL and how you would symbolize them.